Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon problem number 33, search in a rotated sorted array, and this is a lead code medium problem. Let's understand the problem statement. We are given a sorted array, but it has been rotated multiple times. So let's see what a rotated array means. Suppose we are given an array like this one. Now, this is a perfectly good sorted array. All the values are in ascending order, so all the values are increasing. Now, suppose if we take the last value and we move it to the first element, and all the other remaining elements, we move it one step on the right, we would get an array that is something like this. And now this is actually a rotated array which was already sorted, and this has been rotated one time, which we can clearly see here. If we were to rotate this array three times, we would see the same array and it would look like this. So one by one, three elements came to first three positions. And let's see what this problem is asking us to do with the rotated sorted array. And in this array, we are given a target value, and we need to see that whether this target value exists in the input array. If it exists, we need to return the index value. If it does not exist, we need to return -1. And we are explicitly mentioned in the given input problem that we need to find the solution in big O of log n time. Now, there is a golden rule of thumb that whenever logarithmic time is given as time complexity, we can be assured that the solution can be found based on binary search. So let's see how can we apply binary search to our problem to find the solution quicker. Suppose we are given the array like this. We are given the target as 4. So in this case, we can first start by taking two pointers. First pointer as left at the very beginning of an array, and second pointer at the right at the very end of an array. And we would work with middle pointer, and we would, depending on the scenario, we would either move on the left side of the array or move on the right side of the array. And every single iteration, we are going to eliminate half of the given input. So basically, every time our search area would get shorter and shorter, and eventually we would find the solution. So this would give us the time complexity of log n. We have the left side of an array and right side of an array as well, and we calculate the middle value for the given input array. So in this case, the middle value would be at here, and first of all we would check our left pointer with the middle pointer. If left is less than or equal to middle value, we can determine that the whole left sub array from left to all the way mid is already in ascending order, and all the values are increasing. Where for this particular portion of an array, the minimum value we could have would be at the left, and the maximum value we could have would be at the midpoint. So this is a very special property, and because the array is already sorted, though it is rotated, but it is already sorted, so we can use this property and find some interesting results. So now we know that left is less than mid, which means the left portion of an array is sorted. So suppose So we can find out the possibilities when the target would not be in this left portion, and there are two possibilities. If either of those possibilities happen, we would know that target would be on the right side of the remaining array and not on the left side. So first possibility is if the value of target is less than whatever the value of left we have. If this is the case, we know that because all the values that are right of L, right of the left pointer and before mid pointer, they are all greater than the value of L, which means the answer can only lie on the right side of the subtree. Or the second condition is if the target value is actually greater than the middle value we have, because all the values that are left of midpoint, they are actually less than this middle value because of this condition. So we know that whenever the left portion is completely sorted and either of these two conditions meet up, we would need to update the value of left to mid plus 1. Else, if that is not the case, which means that the value lies between left and mid. So we will need, in that case, we will need to update the value of right to mid minus 1. And each time we calculate the value of mid, we are going to compare that whether our mid pointer is equal to target or not. And if that is the case, we can just simply return the value of m that as our result. Now, suppose that this is not the case and we are given some example like this, and we need to find the target value as anything, let's say 9, just for the sake of choosing a value. So in this case, the mid value would be here. Now in this scenario, left less than or equal to m, this condition is going to fail because we know that the value of left is actually higher than the value of mid. And if we check the left portion of the subarray from left to mid, the values are not in ascending order. They are not sorted, and we can see a sudden drop after the value of 6. But at the same time, if we look at the value of right, now at the same time, if we see the value of right, we can see the values are actually in ascending order and this portion of an array is sorted, which means we can use this property to our benefit. So based on this example, we can determine two conditions, that if the given target value is actually less than the mid value, or if the given target value is actually greater than the rightmost value, uh, which means that target value does not fall between mid and right values. We know that the answer lies on the left side of the given array and not on the right side. So we can eliminate all the values from mid to right, and we can only search on the left part of the array. So the condition could be, if this is true, we will need to update the right pointer to check on the left portion. And if this is not the case, and if values do fall between mid and right, we can say that if this is not the case, we need to update the left pointer. We will simply use the given input example, and our target value is 0. We have two pointers defined, left and right, and our middle pointer would become this one. So first of all, we check that whether our middle value is the target or not. And that is not the case, so we move to the next step. We check that whether left is less than or equal to m, which is the case. Now we check that whether the given target value, is it less than left, or is it greater than mid. The target value is less than left, so we need to update the left pointer to search on the middle plus 1. Now the new values becomes like this. We can eliminate the values on the left side because we know that answer does not lie on the left subarray, and this becomes our value of left. This still remains the value of right, and this becomes our mid. Now let's check whether the mid is equal to target. which is not the case. So we move on to next step. If left is less than or equal to mid, that is true. Whether the given target is less than left or the target is greater than mid. None of these conditions are true, which means we need to move the right side pointer, and right would point to middle pointer -1. So now the solution would look like this. These are the values we eliminated in the first iteration, and this is the value we eliminated in the second iteration. Now our left is this one, and our right is also the same one, which means this becomes our middle pointer. Now we check if our middle pointer is the target, and yes, we find that that is the case over here. So we can simply return the whatever the value of mid we find, and that would be our solution. We can say that our time complexity is actually big O of log n, which is the most optimal time complexity we can find. And for the space complexity, we are not using any additional space, so we can simply say it's a constant time space complexity. Let's move on towards coding solution. We will first of all define two values, left and right, and we initialize left to 0 and we initialize right to the length of array -1. Now let's create our while loop. First we will calculate the midpoint. And now we check that whether our midpoint is the target point. So if we return the mid index. Now let's check that whether left portion is sorted or right portion is sorted. If the value of left is less than the value of mid, which means that the array from left to mid is already in ascending order. So now we will check that under what circumstances we can determine that the target value is on the right side of an array. So if in each of the case we need to move the left pointer to mid +1, else we move the right pointer. If right side of the array is sorted, let's see that what conditions we can use that prove that the target lies on the left portion of the subarray. Else we can simply say that the target lies on the right portion, so we need to move the left counter. And if loop ends and we don't find any answer, which means that we need to return -1. Let's try to run our code. Looks like the solution works pretty good. Let's submit it. And yeah, our solution works 100% times better than all the other submissions. So looks like it's pretty convenient, and hope you like the video. Let me know in the comments if you want me to change anything in the video format, or if you want me to do different kind of problems. Thank you for watching, and yeah, see you soon.